Hello again, Year 6. Time for another Year 6 maths meeting. You need something to write with and something to write on. And watch out for our new characters this week. They'll be coming up again. All right, let's kick off with Bobby Mass. Bobby Mass is going to use the order of operation to solve 35 plus 4 times 2. He needs to use BODMAS to solve it. You might want to write down the meaning of BODMAS to help you revise, and then pause your video and go ahead and solve it. All right, let's have a look how we're getting on. Let's use BODMAS to make sure we're using the order of operation. Are there brackets? No, no brackets in this equation. Are there powers of? Are there squared or cubed numbers? Nope, not in this example. Is there division or multiplication? Yes. This gets solved first. 4 times 2, 8, and I've just popped a little reminder above to help me. Because now I'm going to write this equation out again. 35 plus 8. Now we carry on with our order of operation. We've just done division and multiplication. Is there addition or subtraction? Yes, there is. 35 plus 8 gives me 43, which is our answer for today. Great job if you got 43. Moving on now to a Theo thinks. Theo is thinking of a number. He divided by 50 and then subtracted 2. He then divided by 2 and ends up with 2. So what was the number Theo was thinking of? Pause your video and set up your Theo thinks and solve it. All right, let's see how we got on. You should have something that looks like this. Theo was thinking of a number. We don't know the value of that number yet, so I'm using a symbol to show that I don't know the value. Oh, I'm using a symbol that represents value. I'm using algebra. Who loves algebra? Al and Ali. So Theo thinks is an example of using algebra in mathematics. Theo's thinking of a number. He divided by 50. He then took away 2. He then halved it or divided it by 2 and ended up with the number 2. We're going to now use the inverse and work backwards to work out the number he was originally thinking of. He divided by 2, so we're going to times it by 2. 2 times 2 gives me 4. He took away 2, we're going to inverse and add that 2 back on to give me 6. He divided by 50, we're going to times by 50. I could times by 100 and halve it, or I could use my related fact of 6 times 5 equals 30, 6 times 50 equals 300. Theo should have been thinking of 300. Great job, Year 6. Moving on to ratio with Horatio. Horatio has a recipe for 12 cupcakes, and it's just down here in blue. Horatio wants to make 6 cupcakes. How much sugar will he need? Remember, we're using ratio to solve this problem. First job, I'd like you to write down in words the ratio that he's trying to work out. Now we should have written cupcakes to sugar. This is what he's trying to work out with his ratio. Pause your video again and I'd like you to write down the ratio he already knows, the ratio that's going to help him. Now we should have written 12 to 110. 12 cupcakes to 110 grams of sugar. Now that we know this fact, we can simply work out how much sugar he'll need for 6 cupcakes. Pause your video and off you go. All right, let's have a look. For 12 cupcakes, he needs 110 grams of sugar. He only wants 6 cupcakes, which is half of the 12 he already knows. So I just halve my sugar. For 6 cupcakes, he needs 55 grams of sugar, and we write it, as always, in a full sentence. He will need 55 grams of sugar. Great job if you've got that Year 6. All right, moving on now for a Debbie decimal. Debbie decimal is going to make it whole and make it small again. She's going to start with an estimate so that she knows what her answer should look like. So pause your video and write your estimate for 4.3 multiplied by 7. All right, let's have a look. Our estimate, we should have written 4 times 7 equals 28. Our answer needs to be somewhere near 28. You're going to set this up now in a formal written method using a whole number to help you, and then make sure that you make it small again. Off you go. All right, let's see how we got on. I'm going to set it up now as 43 multiplied by 7. I made 4.3 10 times bigger, remembering to make it 10 times smaller at the end. I set it up for short multiplication, and off we go. 7 times 1 is equal to 21, and 7 times 4 is equal to 28, but there's a regroup to give me 30. 301. Oh, hang on a minute. I look back at my estimate. My answer needs to be somewhere near 28, and I've got 301. I made it whole. I need to make it small again. I timesed it by 10. Now I need to divide by 10 to give me 30.1, which is much closer to my estimate. Great job if you've got that one, Year 6. All right, we're moving on to Patty Place Value. She's multiplying 5.01 by 100. And remember, by estimating, you're already solving it. Pause your video and off you go. All right, let's have a look. I know 5 multiplied by 100 is 500, so I know my answer needs to be 500 and something. Let's use our place value chart. There's my 5.01, and I'm going to multiply it by 100, moving it 2 places. Now I've got 500 and something. I've got 501, and no need for any placeholders. Great job if you've got 501. Here they are again, Al and Ali. Al and Ali love solving algebra questions. Let's have a reminder of what algebra is. Algebra uses letters or symbols in place of values. Algebra plays with letters and symbols using special rules. We're going to pause the video and try and write down the definitions for algebra. Off you go. Let's have a look one more time. Algebra uses letters or other symbols in place of values. Algebra plays with letters and symbols using special rules. So let's have a look at algebra in action. For this page, A is equal to 30. When you see A on the board, it is telling you it has a value of 30. So first we're going to solve 2A plus 5, and then we're going on to solve A squared plus 3. Pause your video and off you go. Do you remember from our previous sessions where you see a number right next to a letter? It's telling us that they need to be multiplied. 2A means 2 times A. A equals 30, so 2 times 30 plus 5. 2 times 30 I solve first, that gives me 60, plus 5, 65. Fabulous job if you got that one, Year 6. Moving on to A squared plus 3. A is equal to 30, so this is 30 squared. 30 times 30 plus 3. I know 3 times 3 equals 9, so this is 900 plus 3, 903. Great job, Year 6. Moving on now, it's Formal Phyllis, and Formal Phyllis is solving long division. She's got 1,133 divided by 22, and she's going to use the formal written method for long division. And what's that really important question we ask ourselves? Does my sister burp? Dad, mum, sister, brother. Divide, multiply, subtract, bring down. These things will really help you with that flow and that pattern for using long division. So pause your video and have a go. All right, let's see how we got on. First, we set up our dividend, 1,133. We pop in our divisor, which is 22. Dad says, what is 1 divided by 22? No, we can't do that in this context. 11 divided by 22? No, it doesn't work in this question. 113 divided by 22? That's 5. Mum says, well, yes, but 22 multiplied by 5, it's only 110. Sister says, don't worry, we'll subtract. Find the difference. Brother brings down the next number from the dividend. Dad says 33 divided by 22, that's equal to 1. Mum says, yes, you're right, but 22 multiplied by 1 is only 22. Sister says, don't worry, we'll subtract and find the difference. And Brother has nothing at the moment to bring down in this question. 11 now becomes a remainder. 51 remainder 11. Great job if you've got that one, Year 6. Now, just like before, we're going to look at that answer, 51 remainder 11, and we're going to write it in 3 different ways. Once with a remainder, again with a fraction remainder, and one last time with a decimal remainder. Pause the video and have a go. Okay, let's have a look. 51 remainder 11 is how we write the answer with a remainder. 51 remainder 11. That 11 is out of the 22 I was looking for when I was dividing. So we can write that now as a fraction, 11 out of 22. But well spotted, 11 out of 22 is half, 51 and a half. Now that we have this fact, writing it as a decimal remainder becomes really straightforward. 51.5, 51 and a half. Fabulous job, Year 6, as always. All right, that brings us to the end of our Year 6 maths meeting for today. You've worked incredibly hard. Well done. Keep going. Remember, you can go back through this video and have a look at all of these methods. And of course, as always, they'll be coming up again in our maths meetings. Fabulous job, Year 6. Keep up the excellent work. Well done.